Black holes, an enigma that has puzzled scientists and captivated our imagination for decades. Music, but what's hiding inside of a black hole? Is it a void? A bottomless pit? A parallel universe? We don't know for music sure yet, but scientists might have some ideas. So let's hear them out. Music, picture this. In the vastness of space, there's a supermassive star shining bright like a diamond. But like all good things, music, this star's party, can't last forever. Eventually it runs out of music fuel and goes out with a bang. Quite literally, the star music collapses under its own gravity, creating an implosion. Now, this music collapse is so intense that it creates a bottomless pit in space. Music, like a sinkhole. This is what we call a black hole, the ultimate no-escape zone, sucking up everything in its vicinity, including light. Imagine yourself, music, approaching a black hole. The black hole itself doesn't emit any light, but you can notice a dazzling display of music, cosmic fireworks surrounding it, the accretion disk. It's like music, a celestial carousel of gas and dust, whirling in a mesmerizing dance around the black hole. The incredible music, gravitational forces pull all this material from their surroundings, creating this celestial furnace. Of course, music. It's very unlikely that you would have survived in this place. Temperatures here soar to millions of degrees. Also, it's constantly dazzling X-rays, music, and high-energy radiation that can be detected from telescopes on Earth. But let's imagine music that you did survive. Somehow, as you get closer, you music notice a mysterious boundary looming ahead, the event horizon. It's a point of no return, beyond music, which the laws of physics seem to go haywire. Now you're stuck in a space traffic jam, and no matter how hard you hit the gas, you're going music nowhere. Once you cross this threshold, not even light can escape, and now you inevitably music fall into a black hole. What do you see around you? According to music, the genius physicist Albert Einstein, space and time aren't separate entities, but rather music, intertwined in a fabric called spacetime. It's like a cosmic music trampoline that can stretch and bend if you place something heavy on it. And black holes are super heavy, which is why they distort music, this trampoline, in the most extreme way possible. So when you venture music close to a black hole, you're in for a roller coaster ride. The curvature music of spacetime becomes so intense that it's like a whirlpool, pulling everything music in, even light itself. Everything around you looks like a space funhouse music with distorted colors and rays of light that keep shifting. All this makes you feel music like you're doing the moonwalk on a treadmill. Also, music, the curvature of spacetime around a black hole is so extreme that it creates a phenomenon called time dilation. Music time near a black hole moves at a different pace than in the rest of the universe. The closer you are to the black hole, the slower time ticks, like a slow motion effect. Music, and the deeper you fall, the weirder things get. The laws of physics seem to break down before your very eyes. But suppose you somehow manage to survive all this madness. Where exactly music are you falling? What awaits you on the other side? Is there even another side? As you venture music deeper into the celestial maelstrom, you reach an elusive and mysterious point, led the singularity. It's the heart music of a black hole. A place where all matter and energy are crushed music into a single unimaginably dense point. Imagine cramming masses of entire music stars to something that is essentially a pinprick. And now that you're here, forget about the usual music rules of physics. Welcome to a new realm where the known breaks down and the unknown takes over. So what does music, this unknown, look like? Well, there are a couple of theories. First off, it could be a gateway to music, other dimensions. What if there are multiple universes hiding within black holes' music like nesting dolls? According to this theory, the interior of a black hole could be a music portal to a parallel universe with its own set of physical laws and possibilities. Music. This parallel universe could be drastically different from our own world. What a mind-bending idea. Or what about wormholes? Music. Imagine black holes forming a space subway system, connecting different regions of space and time with each other. These theories suggest that the extreme gravitational pull of a black hole could create a wormhole, music, a tunnel that could transport you to another galaxy or even to the past or music future. It's like finding a secret passage in a video game. Music, that's not all. Some scientists propose that inside a black hole we might find some exotic matter, some strange music matter with weird properties or negative energy density. If that's the music case, this would defy our understanding of the universe. And finally, music, one of the most mind-bending theories is that a black hole could actually lead to a white hole. Imagine music as you fall further, you suddenly find yourself in a blindingly bright space music show. You're in a white hole. This is a fountain that's spewing out matter, energy, and information into the universe, music with reckless abandon. The birthplace of new universes. You see, while black holes are known for their event horizon, white holes have an anti-event horizon. With black holes, everything can enter and nothing can come out. With white holes, it's the other music way around. They repel everything. White holes are hypothetical objects. Their existence hasn't music yet been proven. But if it turns out that they exist, they could be connected to black holes. It makes sense. Black hole. Suck everything in. And white holes should, music, take their matter from somewhere. And all this matter and energy coming out of the white hole could potentially form music, new universes. Together with black holes, they could form a universal cycle of creation. The end of one music universe leads to the birth of another. All these theories are beautiful music and fascinating, but here's the catch. There's still no concrete evidence of any of them. Music black holes still remain one of the biggest mysteries music of our world. Unfortunately, studying these mysterious beasts isn't easy. They're super elusive. Music, and this is one of the biggest challenges for scientists. Black holes don't emit light, so music can't be seen directly. They're essentially invisible to telescopes that rely on light, making them incredibly difficult to observe. That's why scientists have to rely on things like X-ray emissions, music, the effects of a black hole's gravity on nearby objects, and other clues. Their music also very unpredictable. For black holes, physics is like a fun playground. Music, they warp space and time around them, which makes music difficult to predict and understand their behavior. But don't worry, music space enthusiasts. The future of research in this field is as promising as ever. We've already made incredible discoveries. For example, in 2019, we captured the first ever direct image of a black hole. This music is a central black hole of the galaxy Messier 87. A few years later, we also took a photo of a black hole in the center of our own galaxy, the Milky Way. This one is called Sagittarius Music, a star. All this has opened up new avenues for research. And these aren't the only cool things we've discovered in recent years. Let's take gravitational waves, for example. You know how rocks leave ripples after falling into water? Well, gravitational music waves are ripples in the fabric of space. They carry clues about music, the most cataclysmic events in the universe. They've allowed us to listen to the universe, unveiling previously hidden phenomena and events. And all these observations, provide us with a new way to study black holes. We constantly make new advancements in technology. The James Webb Space Telescope will provide us with even more detailed observations and insights into the mysteries of black holes. There's music, still so much we don't know, but that's the beauty of science, the thrill music of the unknown and the curiosity that drives us to explore the mysteries of the universe. So, music. Let's keep peering into the cosmic abyss on the thrilling quest to unlock the secrets of our world. You're traveling through space, trying to get through an especially rough patch. You got to dodge asteroids, space debris, wandering black holes. Now, it's not an episode of a sci-fi series, at least not completely. For the first time ever, astronomers have found a black hole that's completely alone, drifting through space with no stars or planets nearby. This black hole music is about 5,000 light-years away from us in our Milky Way galaxy. Do we need to look for a hero with superpowers to save Earth? First things first, a black hole is a place in space where music gravity pulls so much that nothing, not even light, can get out of this region. The gravity is so strong there because a huge amount of matter is squeezed into a tiny space. Supermassive black holes, hundreds of thousands to billions of times the mass of our sun, are often found at the centers of galaxies. Most of them stay put or move at a very, very slow pace. But the newly discovered black hole is much weirder than anything we've seen before. First of all, it tries to avoid commitment. It's lonely with no companion star or home galaxy. An even stranger thing is that it's zooming through space at a speed of 31 minutes per second. What might be a reason for this speedy cosmic journey? Let's look at the following imaginary scenario. One day, a really massive star exploded in a supernova. It was the very music star that formed our black hole. The resulting blast gave the new black hole a massive kick, and music sent it flying through the galaxy, starting its unbelievable voyage. Now, music, it's only one of a few possible explanations. But it sounds quite plausible. I bet you can't help but think, what if this wandering music black hole decides to visit our solar system? Are we doomed? Scientists tell you music to relax and breathe out. This black hole is very far away, and your music chances of ever encountering it are infinitesimal, if any. Plus, this black hole music is totally quiet and dark at the moment. Oh, day, it might wake up and start glowing. It'll happen music if it begins to eat something. In the near future, powerful new music telescopes may find many more wandering black holes like this one. Usually, music black holes are super hard to find because they don't give off any light. You can only detect them when they're eating nearby matter that makes them glow brightly, or when they have a companion star. In this case, it moves in a strange way which gives away the presence of a music black hole. But this newly discovered black hole is lonely, totally by itself. There's no glowing, no companion star moving hectically. So, music. How did scientists spot our cosmic wanderer? They use something called gravitational microlensing. That's when the music black hole's gravity bends and magnifies the light from a star located behind it. Kind of like using a music magnifying glass, hence the name. This method allowed scientists to detect the black hole, even though it was completely dark. All in all, black holes are fascinating things, and some of them are truly unique, like these biggest black holes music ever found. You see, almost every galaxy has a supermassive black hole at its center. They're huge, with masses millions to billions of times bigger than our sun. One of those is called Ton 618. It's a really huge and powerful music black hole that's part of something called a quasar, a super bright spot in space emitting incredible amounts of energy. Ton 618 is very, very far away, about 18.2 billion light-year from Earth, and it's 40 billion times heavier than our sun. There are also black holes that feed on their own kind. Black holes are known for devouring anything that music gets too close. And this anything can include not only stars and gas, but also other black holes. Scientists witnessed a ginormous black hole at the heart of one galaxy being swallowed by an even larger black hole in another galaxy. It was the first time we detected such an event. The discovery was made using NASA's Chandra X-ray Observatory. One black hole weighs about 30 million times the mass of the Sun, while the other has at least 1 million times the mass of the Sun. Then there is a bullet-shooting black hole. Apparently, music black holes don't just swallow matter. They can also shoot it out. For example, music astronomers studied one relatively small black hole. CH is about 28,000 light-year from Earth and weighs between 5 to 10 times the mass of the Sun. And they saw how this black hole pulled matter off a companion star, and then music blasted some of it out in the form of huge bullets of gas. These bullets are super fast. They move at nearly a quarter the speed of light. Some black holes spin incredibly fast, twisting space around them at extreme speed. One example is a black hole located in the constellation Agila, about 35,000 light-year from Earth. This black hole spins at a staggering speed of more than 950 times per second. If you could place an object on the edge of this black hole's event horizon, it would spin around the black hole at 333 million mph. That's nearly half the speed of light. The smallest black hole discovered so far has been music, nicknamed the unicorn. Located 1,500 light-years away from Earth, it's around 3 times the mass of our Sun. Music, this makes it very close to the smallest possible size for a stable black hole. While black holes themselves are far away and difficult to study directly, scientists find new clever ways to study their properties right here on Earth. They've been able to recreate certain features of black holes in the lab. For example, black holes have a gravitational pull so strong that nothing, including music, light, can escape once it crosses the event horizon. To understand this better, researchers have created an artificial event horizon using fiber optics. They've also been able to simulate Hawking radiation, the kind that likely escapes black holes, by setting up experiments in the lab. These lab-created mini black holes help scientists understand the mysterious properties of real black holes. There are several types of black holes, and each of them is born in its own unique way. Primordial black holes are believed to have formed music right after the Big Bang when the universe was very young. Stellar black holes form when a massive star collapses in on itself. This causes a supernova where the outer layers of the star explode into space and the core turns into a black hole. As for supermassive black holes, they're thought to have formed alongside the galaxies they're in. The size of the black hole is usually related to the size and mass of the galaxy. Despite what many believe, black holes don't roam the universe randomly looking to swallow planets. They obey gravity like anything else in space. So for a black hole to affect Earth, it would have music to be very close, much closer than any black hole is to us right now. Even if a music black hole the same mass as the Sun replaced our Sun, Earth wouldn't fall music into it. The black hole would still have the same gravity as the Sun, and Earth would continue orbiting it, just like it orbits the Sun music today. It would get much colder though, so we wouldn't survive such a replacement in any case. But don't worry, our Sun will never turn into a black hole. It doesn't have enough mass to do so. Instead, in music about 5 billion years, when the Sun reaches the end of its life, it'll become a red giant star. After using up its fuel, it will shed its outer layers, creating a glowing ring of gas called a planetary nebula. What's left will be a cooling music white dwarf star. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright.